So this section here is similar to the last chapter where we went through and came up with, oh wait, this doesn't have any solutions, I think. Or anyways, so sometimes you had like infinite solutions, sometimes you didn't have any solutions. Yes? Sure. So this is kind of a repeat of that. Basically, the notes are just saying, okay, the first thing, combine all the x's together, then solve. So combine all the, maybe I'll say variables together. Usually it's going to be x, then solve. Or it might be you're trying to combine all the y's together, but you can't combine an x and a y. Agreed? Cool. All right, so if we have one like this, well, we could do it one of two ways. Do you want to subtract x from both sides or subtract 4x from both sides? It's really kind of up to you. I don't like leaving this side here with nothing left. So that makes me want to subtract 4x, but as soon as you subtract 4x, then you get down into negatives, and I don't like negatives either. But so I think I probably would do the minus x like a lot of you guys said you would. 4x minus x is? 3x. So we have a 3x minus 7 is greater than what's left on the right side?
0.
0, perfect. So we had an x, we took it away, so there's 0 left on that side. And now to solve, we just kind of go like normal. So first step would be to? Plus 7 plus 7. 3x is greater than still?
Yeah.
7. Next step is to divide by 3. And we only flip the sign when multiplying or dividing by a negative. So we have x is greater than, you could say 7/3. You could say, would it be 2.3 repeating? It's totally up to you. 7 over 3, 2.3 repeating. Any one of those. And graphing that, you guys would be okay graphing it? Awesome. If you were to take a second one like this, first step would probably be best to distribute. You could try to divide everything by 4, but then you're going to get this like this kind of awkward like 5/4 x over here. So I like distributive first. I think that's a good first step. So 4 times 8 is 32. And then I have a 4 times a minus x gives me minus 4x or negative 4x. Is it still less than? Yep. So I didn't multiply or divide both sides by something. So I have my 5x. Next step is to? Perfect. So if I do the plus 4x, and it gives me a 32 is less than 9x. Last step, divide by 9. Those drop out. So when I do that now, I have 36. Anybody want to help me on that one? 3.5 repeating, thanks. So 3.5 repeating.
I think that's right.
Now, if you had to graph this one, some people would prefer to put the x on the other side and say x is what? Nice, greater than. So if 3.5 repeating is less than x, the other way to say it is x then has to be greater than or has to be bigger than. But I'd be okay with either one of those answers. If you write this down, that's totally fine. Totally fine. Nasty decimals. A lot of people take one like this, and they just go through and do the whole problem with like the decimals in there. There's absolutely nothing wrong with that. In some respects, there's less chance of making a mistake in getting rid of the decimals. But if I am here, I could take and move this decimal point 2 places, so it's 427x, by multiplying by what number? Not 10, but 100. Because if I multiply by 10, it's going to move the decimal point 1 place. Multiply it by 100 moves it 2 places. So if I look, I have 2 decimal points here, 1 there, 2 here. So if I multiply everything by 100, that's going to take and move all of those decimals 2 places. So I'd have 427x minus anyone?
1.
Nice, 120. A lot of times people just say 12, but you have to remember that multiplying by 100 takes and moves all the decimals then, each of those clumps, 2 places. So you have to go to 120. Is less than 2,478. Now you don't have the decimals, but you're working with bigger numbers, which is kind of a pain just in a different way. But you guys okay on solving that one?
Mm-hmm.
Should we work through it to the end, or you're like, I'm good? Okay. Then, all right, so the last section, so we have kind of these first initial problems saying they're just kind of ugly numbers for different reasons. If we were to go through and solve this baby, the kind of hint is going to be, it's going to be one of those either where there's no solutions or all real numbers are solutions. We just need to figure out which one. So first step is going to be to do what to both sides? Yep. So I'm going to take the x's and subtract x to move all the x's to one side. When I do that, my x's totally drop out, and I get a positive 4 is greater than or equal to? Yes? Yep, because I subtracted x. If I divide or multiply by negative, then you flip it. Okay. 4 is greater than or equal to negative 8. Sometimes true, always true, never true.
Never.
4 is never bigger than or equal to negative 8? Oh, you thinking the equal to?
Yeah.
Okay, but is 4 always greater than?
Yeah.
Yep. So this one here fits. In other words, what we just found is it doesn't matter what you put in for x. If you put in a 2 in both cases, then you're going to get 6 is greater than or equal to negative 6. Yep, 6 is bigger than negative 6. If you put in a 10, you'd have 14 is greater than or equal to 2. Yep, 14 is always bigger than 2. So do you see, it doesn't matter what x is. We're always going to get a statement that's true. So is that no solutions or all real numbers? Yep. So if it's always true, so then you could say the solution equals all real numbers. If you were to get something that's never true, so say you have like 8 is less than or equal to 6. Just totally made up like a new question. But do you agree 8 is never less than or equal to 6? So then if you get something that's never true, does it matter what x is? No x values would ever work for that once the x's drop out. So if it's never true, then the solution solution equals no solution. Yep, should have actually looked at my notes before starting to talk. So if it's never true, you get no solution. Sorry, kind of crash and burn there at the end, but makes sense? Yep. Okay.